Hi, welcome to N6.8. This is Demonstrate an Understanding of Ratio. Now, ratio is kind of just a fancy way to write, or another way to write a percent or a comparison. And so what you have to do with a ratio is be able to show it concretely, which means with objects, pictorially, which means draw a picture, and symbolically, and that means with writing. So demonstrate an understanding of ratio in 3 different ways. Our indicators say observe situations relevant to self, and so we can talk about a few of those coming up. B says critique, and critique means tell whether it's true or not and be able to defend it. So critique the statement, ratios and fractions are the same thing. Now I've already told you they're sort of related, but I don't know that they're the very same thing, so we'll get into that. That was B. C says create representations of and compare part-whole and part-part ratios. So you already know there's 2 kinds of ratios. One shows part to whole and one shows part to part. Now that might be part of your argument in this guy here, because we know that fractions show part of a whole, which is right here. But fractions don't show part to part, so that's where ratios are a little bit different. Okay, the example they've given you is, from a group of 3 boys and 5 girls, compare their representations, boys to the entire group, and girls to the entire group. So we have 3 different numbers showing here. 3 to 5, which would mean 3 boys and 5 girls, so this would be part to part. Then we have 3 to 8, and that would be boys to the whole group. So 3 to 8 is boys to the entire group. And then comparing girls to the entire group. So 5 girls and there's 8 in the whole group. So there is our part to whole and part to part. A little bit different from fractions. Express a ratio in colon and word form. So a colon or a colon is this double dot thing, colon. So 3 to 5. So we say the ratio, if we're going to write it in word form, 3 to, make sure you're using the right to, this is TO, 3 to 5. When we're saying a ratio and we see it like this, we say it just like this, 3 to 5. E, describe a situation in which a ratio given in colon, word, or fractional form. So now we know from this little hint right here, we can write it in a colon, we can write it with words, or we can write it in fractional form, 3 to 5, or 3 out of 8, because we said there were 3 boys and there's 8 in the whole group. Lastly, this one says solve a situational question involving ratio, and I have this exact question coming up, so we'll have a look at that in one of the next slides. So why do we need ratios? Well, somebody made this necklace and they used a ratio. So we can tell we have different colored beads in here. We have green, we have pink, we have white, we have gold, and we have, I think that's about it. So we can tell that green is the most commonly used bead in this necklace. They didn't use a pattern. They didn't go, oh, 2 pinks, then a green, then a white. You can see sometimes there's 3 whites. If you look at that row, sometimes there's a whole bunch of green and no pink in there. Sometimes there's a whole bunch of gold. So they didn't use a pattern, but what they did use was a ratio. They decided that they wanted maybe a 80% green necklace, and they wanted pink to be 10%. So now we're up to 90%, right? They wanted white to be 5%, and they wanted gold to be 5%. So once they determined what kind of ratio they wanted, let's say they used 1,000 beads to make this. Okay, so we would say, well, 80% of 1,000, we could figure that out with our calculator, or we could just do mental math and know that if we're using 1,000 beads, 0.8, which is 80%, so up here I'm just going to write in 0.8, very little. Okay, 0.8 of 1,000 would be 800 green beads. 100 pink beads, 50 white beads, and 50 gold beads. And that all equals 1,000. So 800 plus 100 is 900, plus another 100 is 1,000. So we've got our numbers. Now, if we were going to write this as a ratio, we could do it in two different ways. Remember, there's part to part, and then there's part to whole. So that's the tricky part about understanding ratios is, are they talking about part to part, or are they talking about part to whole? So if I said, let's talk about part to part for a minute, what is the ratio of white beads to gold beads? Well, the white part says we're going to do 5%, and the gold part says 5%, so it's 5 to 5. We could reduce ratios just like we do fractions. What I do to this side, I must do to this side. So if I'm going to divide by 5 on both sides, I end up with a ratio of 1 to 1. But let's talk about part to whole. If I'm going to talk about the gold beads, so my gold beads are 5%. My entire percent for the necklace was 100. So 5 out of every 100 are gold. I can reduce this down as well, and this can be 1 out of every 20. If I divide by 5 on this side, I must divide by 5 on this side. Okay, next slide. Now, here's examples of some different ratios. Sometimes you see ratios written like they are in this magnifying glass, 1 to 1. So that would mean for every gold bead, I put in a green bead. So 1 to 1 is like saying 50-50, right? Or it's like saying they each have an equal chance of being in there, right? So it's equal. Equal parts. 1 to 1 is the same as 50-50 is the same as equal parts. Here is a real life example down here in the bottom. If you're going to make cake, maybe you would have 2 cups of flour for every 1 cup of sugar, and that's the ratio for your cake. So if you wanted to double your recipe, and I want to put in 4 cups of flour, how much sugar would I put in? Well, if I used to have 2 to 1, and now I have 4 to something. What did I do to the 2 to turn it into a 4? Well, I multiplied it by 2. So that's my magical recipe. I must do that over here. I must times it by 2. And 1 times 2 is 2. So if I have 4 cups of flour, I need to have 2 cups of sugar. Okay. Looking at these stars and circles, it says the ratio of circles to stars is, and we're looking way down here at the bottom, 4 to 7. So there are 4 circles and there are 7 stars. So they've written it with words, then they've written it with a colon, and then they've written it as a fraction. Sorry, my circle is bad. All right, so these are all part to part because there are 7 stars. So this is circles, and this is stars. Okay, So this is an example of part to part. If we were going to ask, what is the ratio of circles to all the shapes, then that would be part to whole. Okay, let's go to the next slide. Now here's a real life example of where you might have seen ratios. You might have seen this on your TV screen. You might also have seen this one, 4:3. These are the most common ratios that you see on a TV, and what they're talking about is length to width. So it goes width first. So on this computer screen that you're watching this video on, it's probably a 16:9. It could be a 16:10 depending on the size of the computer, but usually they're set 16:9. If you're watching it on a digital camera, and you can see digital cameras are quite often 4:3. Your TV at home is probably a 16:9. And you can set your TV to show different ratios. And so what ends up happening is maybe you have a big screen. Let's use this 1.85 to 1. Let's say you have a cinema in your house. Lucky you. If you try and show a movie on it, you might only be using this area of the screen, and then this stuff down here is just all black. And you've probably seen that before on different movies that have they were recorded in different ratios. So there's a real life example of where we actually use ratio. All right, on to this last one, solving a situational question. So it says the ratio of students in grade 6 going to the movie this weekend to those that are not going. So watch for this little word, because that's where your colon would go. And we're talking about who's going and who's not going. So 15 are going, 8 are not going. And it asks you how many students are likely in this class. So let's talk about that. We have 15 going, 2, 8 not going. So how many students are there in the class? Well, how do we figure that out? Well, they've given us a part, the part that are going, and they've given us the part that are not going. So when you have a part to part ratio, you can add those two parts to get the whole. So 15 and 8 is 23. So there are obviously 23 students in this group. 15 of them are going, 8 are not. So if you wanted to write your ratio as part to whole, you could say 15 out of 23 are going. You could write it as a fraction. 15 out of 23 are going. You could write it as we've done up here with the colon. So there's two different ways to write ratios, and that might be the confusing part for some students is, are we talking about part to part, or are we talking about part to whole? So you kind of have to read the question and figure out what they're asking for, because sometimes it's hard to tell. Good luck with ratios.